Welcome, and in this next video we're going to show you how you can write a subroutine that will wait for a high on pin B bit number 1. So I've already done the org, and I've also set up the DDRB so that pin B bit 1 is a input, and you can see that is done right here with this first 0. This DDRB should not be in any loop. It should be done once, left alone, and then you go into some sort of looping. So I'm going to write a subroutine and come down here, and we're going to say wait for high. That's my name of my subroutine. Wait for high with a colon, and we're going to need to let's see here. We need to bring this in. So we're going to say in R16 comma pin B. This will bring all 8 bits into R16. Then we will need to isolate that one bit. So we need to do an AND immediate R16 with a bit pattern in base 2, and we want to keep that 1. So here's the way that 1 that you see there will keep bit number 1. And all others will be a 0. Now I'm waiting for a high. So I'm going to compare R16 with what I want to have happen. I want to get a 1 there. I'm going to compare it to that pattern because I want a 1. And I will branch if I'm not equal to, if I don't get this, I want to branch. So it's a branch if not equal to that, and I will go back to wait for high. In fact, you can go right back to that same label where we input the pin and right, input and it, compare it, branch if not equal, and then we can do a return, RET. Now this will work. And I'm going to come up here in the main program. I'm going to say rcall, wait for high, and it will go there and wait for a high. When it comes back, we're going to just idle. So I'm going to say main 0 colon r jump to main 0, just so it has some place to go to. And if I didn't have this main in the jump, it would fall into the subroutine, which is a bad idea because it will hit the return and then crash. The program will crash because of the issue with the stack. It won't like that. So I have to make sure that the main program doesn't fall into any subroutines, but rather only calls subroutines and then returns back from them. And again, that's why I have the main and the rjump here. Well, this will work. Let's compile it just to make sure we don't have any. It compiles fine and it will run fine. But here, this alters R16 in the subroutine, and I would rather not do that because the main program up here could potentially be using R16 for an important function of some sort. So if you're using R16 in the main program, this subroutine is going to kill it and give it some other value, and you may not be happy with that. So to keep you happy, what we're going to do is to put in a push R16 so it saves it on the stack, and we got to pull it off the stack with a pop R16. This will compile, but you notice maybe that this will be very bad the way I have it. It's not going to run because the branch here goes to the wait for high, which pushes R16 again, comes to here, and then it comes back up here. And how many times will this push R16 out of the stack? Well, like a gazillion times with no popping. So this branch needs to go here, and we will put a wait for high _1 colon. This is a good naming practice so that we don't so that we don't reuse labels inappropriately. The subroutine is now good, but I'm going to build this to make sure. Yep, the build is good. So here's our subroutine. It pushes and does the pop. It's got the loop, which is good. We come back to the main program and we, yep, it all looks pretty good right there. So it's a pretty straightforward thing to do. Set up your DDRB first, go into subroutine, maybe push your registers and pop them as you enter and leave. The task is to do an in, an and a compare. Okay, so yeah, let's stop the video at this point.